So I'm gonna be a little lazy today, and I'm gonna use the scoring guideline for 2004, question 4. So no calculator. All right, Form B. The figure above shows the graph of f prime. You've got to catch this, guys. This is the graph of the derivative. Okay. On the closed interval, -1 to 5. So that's the domain of f prime. The graph of f prime has a horizontal tangent at 1 and 3. You know what? I'm not even sure why they told you that. Couldn't we tell that there was a horizontal tangent at those points? So we know f prime prime is 0 there and there. Do we agree? Immediately. What thing? Cursor. Yes, please do. Thank you. And we know initial condition. So I'm thinking that somewhere there must be a fundamental theorem of calculus coming. All right. That's just my guess. I haven't done the problem yet. But again, so here we go. Find the x-coordinate of each of the points of inflection of the graph of f. Give your answer for the incomplete. Again, here we go. What did I say immediately? That there are two possible. F prime prime was 0 at 1 and 3. So those are points we have to check. These are possible points of inflection. This does not make a point of inflection. And what do we see happening? If the answer is 1 and 3. And let's go through why. Okay, they both are points of inflection because, and look how they did the reason. F prime changes from increasing to decreasing. Thus, that is a point of inflection. And that's for that one. And at 3, it goes from decreasing to increasing. You could even have said F prime prime goes from positive to negative, but you have to say it's F prime prime, not F prime. I much prefer to talk about the graph they have. So listen though, even if you just wrote x equals 1 and 3, remember I always talk about this with the justification problems. First things first, answer the darn question. X equals 1, x equals 3. Give yourself a point. Then you had to talk about, with the first derivative, that it was increasing to decreasing and decreasing to increasing, or that the second derivative went from positive to negative and negative to positive. Language is important. All right? At what value of x does f attain its absolute minimum value on the closed interval of -1 to 5? At what value of x does it attain its absolute max on the same interval? Show the analysis.
To the office, please, Kelly.
All right. We know, again, we know that f, this is the graph of f prime, that most likely this is going to occur when one of 4 spots. When f prime is equal to 0 or 2 endpoints. Does everybody agree? So I have to check 1, 4, 5, and -1 for x values. All right.
To the office.
If I do that, it says here for letter B, function decreases from -1 to 4. All right. Then increases from 4 to 5. And what they're looking at is they're just looking at the value, right? All right.
Good morning, everyone.
Therefore,
Just like to remind everyone that today at 3 o'clock.
All right. So I'm going to take a second here. What you got to catch at 1 is that it goes from negative to negative. So it's not a min or a max. So the first thing I would have wrote somewhere here is that at x equals 1, there is neither a minimum or maximum because the sign doesn't change on the first derivative. They didn't write that out here, which is weird. But I get it. But listen, but you don't ever know what you're going to do. So that's the first analysis I would have made. Does everybody agree with that analysis?
Yeah.
Now that leaves 3 points to check: -1, 4, and 5. And when you look at 4, it goes from negative to positive. Negative to positive is going to be a local min. So that's what I would have said. So there's a minimum value at 4, and they said that here, okay? I would have to calculate now the value at -1, 4, and 5, all right, and see what the values are. The absolute max must occur, because it asks for the absolute min, too. And it says, therefore, the absolute minimum value is at 4. How do you know that? You got to compare the endpoints, too, but here we go. So the absolute max must occur at -1 or 5. So you do f of 5 minus f of negative 1 is what they did here, and they find that that is less than 0. Yeah, see, that's not the way I would have done this
How
problem.
did they find the value?
Yeah, I would have started from f of 2 equals 6.
This is the integral. Hey, Mr. Anderson, how do they find the value?
I don't even know how they know that that's less than 0. I'm coming back. Hang on a second. You're looking at the graph, because listen, it's negative. They're doing the graph. They're looking from negative 1 to 5, and they're saying, based on the graph, they're saying this area is greater than, it's greater than this area. That's what they said. I know, you're rolling your eyes. So therefore, you know that as you go to the right, it's going to get smaller and smaller. You can, and that's what they did here. That's what they did. They said this is less than 0. Therefore, yeah, I know. It would make a difference. But this is where it's set. This is where it's set. So they call the maximum value at negative 1. They call the minimum value at 4. And you eliminate. But see, I don't know how you can make sure that 4 is more minimum than. Oh, I know. How do you know 4 is more minimum than 5? How do you know the value at 4 is more minimum than 5?
Well, it gets positive.
It gets positive. It starts increasing after
So
4.
they counted the negative area as.
They just did it as a inequality.
They said negative was greater
Yep.
than positive, but that's not true.
The negative, well, no. The negative area here is greater than the positive area
Yeah,
here.
but if something's more negative, then it's a lower number, so it's minimal.
Right. So they're saying that. They're saying that negative 1 has to be a maximum compared to 5.
Oh.
Okay. All right. All right. Last one. Don't walk off. I know the bell's rung and you can hear the traffic in the hall. Just hang on. We will finish covering this on Monday, but look at what they did for the derivative.
So they asked for the equation. You wouldn't even have to get them numbers.
Well, listen.
They
First,
didn't ask for a value.
they gave you the point, didn't they? You have to find f of 2. They gave you f of 2 is 6. You find the slope. You find the new point. You find the tangent line.
They didn't give you the 6.
They gave at the top. They gave you f of 2 equals 6,
Oh.
and then you use that to find g of 2. You have to
What
find
is it?
g of 2 is 12.
Oh, it's
The
not.
point is, yeah, it is.
Oh, it's not.
Because what is the value? What is g of x? G of x is x times f of x.
Yeah.
So you plug.
Proved it.
Okay, so you plug in g of 2, you get 6 times f of 2. What is f of, or not f of 6, it's 2 times f of 2, sorry. And what is f of 2? F of 2 was 6, so g of 2 was 12. That is your point. How do you get the slope? You get the slope through the derivative. You get 2 points for 4. If you show g prime of 2 equals 4, give yourself 2 points. If you found g2 of 12, you can find the equation of the tangent line, which is worth a point. This is always worth 9 total. Always 9. All right, we'll kind of review this again on Monday. This is not the world's
What is
greatest.
this up?
This is not the world's greatest definition.